In example 16, I have x squared plus 9, and I see that is x squared, and that is 3 squared. But look at this, that's a plus, not a minus. This is not the difference of two squares, this is the sum of two squares, and I can't factor it with that pattern. The pattern we've been looking at, thing 1 plus thing 2 times thing 1 minus thing 2, only applies to the difference of two squares, and this is not that. So this can't be factored. You can write it does not factor. Or if you want to, you could use the term irreducible. That just means it can't be reduced to its factors. It's irreducible. Now number 17, this one will factor. And this is kind of interesting. This doesn't look like the difference of two squares. I see a squared, that's clearly a squared, that's something squared. But 7 is not a perfect square. So I have one thing minus another, but this second thing isn't something squared. But 7 is something squared if you think about it. What squared gives you 7? Well, the square root of 7 gives you 7. So I can think of this as a squared minus the square root of 7 squared, because the square root of 7 squared is in fact 7. So if I think of it that way, this is the difference of two squares, and this can factor as a plus the square root of 7 times a minus the square root of 7. And let's do a FOIL on that just to see it work out. The first gives me an a squared. The outer gives me a minus a times the square root of 7. The inner gives me plus a times the square root of 7. And then the last terms give me a minus, and I have the square root of 7 times the square root of 7, which is just 7. And sure enough, the minus a root 7 and the plus a root 7 cancel out, and we're left with a squared minus 7. So it works. Now example 18 is also interesting. I have x squared times a minus 5 minus 9 times a minus 5. Now this doesn't look like the difference of two squares. The only thing I see squared right here is the x. But I do see two terms, and each term has an a minus 5 factor. So I can factor that out. I think in my mind, x squared times this thing minus 9 times this thing can be written as x squared minus 9 times this thing. And that thing is the a minus 5. Now, it's factored. I have two factors, and those two factors multiplied together would give me the original expression. But now look, this factor, the x squared minus 9, that factor is the difference of two squares, x squared minus 3 squared. So I can factor that piece again. I'm going to have this, just that, can be rewritten as x plus 3 times x minus 3, and then I still have my a minus 5. So my original expression in this case breaks down into three factors, and there they are. X plus 3 times x minus 3 times a minus 5.